Hello everyone. So hopefully everyone is doing well. We are going to start today our very first lesson for pre-calculus. So hopefully you are ready for that. But before we get started, what I want to do with you guys is first I want you guys to pull out your notebook. So you're going to be pulling out your notebook, and so what's going to happen is, so you're going to open up your notebook, and then you're going to flip a page. So like for me, it might be looking a little bit different, but on the first page, I would first write this right here. So I would be writing pre-calculus, the title of our class, Mr. Rubio, so the name of my name, and then our period, which is period 1. So I will give you a couple of moments to write that down, and then we'll get started. Okay, so now that you've written that, what I'm gonna do is we're gonna flip to the next page, and the next page you're gonna see that we're gonna have a rubric for us right here. So I'm going to zoom out. This is gonna be where we write our learning targets. But for you guys, I have provided the rubric for you guys for the learning targets on Schoology. So if you would like to print it out, you're more than welcome to print it out and then paste it on here. But I wrote it down. But for the sake of time, I'm gonna have you guys do that on your own time. So just make sure to make just provide one page for you guys to do the to post up like your learning targets, and then we'll go from there. Okay, so we're gonna get started and go on to our first lesson. Okay. Okay, so the first lesson we're gonna learn today is we're gonna be reviewing some trigonometry, which is something that you learned in geometry. So I'm gonna give you a moment to write down our title and write down today's learning targets. So you will be tested on this. This lesson we're going to learn about is going to touch on learning target number 1 and learning target number 3. So learning target number 1 is you're going to be tested to see if you can use SOHCAHTOA to find the missing sides of a right triangle. And then learning target number 3 is going to test you on whether or not you can solve word problems involving right triangles. So I will pause it right now for a little bit, give you a couple moments to write this down, and then we will proceed on to the lesson. Okay? So I will pause it right now. Okay, so now that you've written that, now I'm going to require you to write down this next part right here. So this is going to be our trig ratio recap, and again I will explain it, and then you write it down as we go. So this is a quick recap for you guys, so we're just going to go over like some of the ratios that we learned before. So first we're going to start off with a triangle, a right triangle, and we're going to say let theta be an acute angle of a right triangle. And then the 6 trigonometric functions are as follows. So we're going to be looking at sine, cosine, tangent, cosecant, secant, and cotangent. So to explain that a little bit, you're going to have a right triangle, and you're going to start with an angle theta. Remember, keep note that when we look at these right triangles, our angle theta is an acute angle, so we can never start right here at the right angle. So it would be either this angle or that angle. Okay, so just keep that in mind. Now, if you notice, so the way we're going to look at our trig functions is when you start here at your angle theta, you're going to be looking at an opposite. So the angle that's right across from it, that's what we're going to call the opposite side. The side that's right next to this angle right here, theta, is going to be called adjacent. So adjacent means right next to it, so the angle that's right next to it is the adjacent. And the hypotenuse is going to be a side that's right next to this angle. However, the hypotenuse is always the side that's right across from the right angle. Okay, so just differentiating between what adjacent and hypotenuse are. Adjacent is the side that's right next to the acute angle, and hypotenuse is the side that's right across from the right angle. Okay, so keep that in mind. Now, we have 6 trigonometric functions that we're going to be talking about. So the first one, let me explain it to you. We're going to have, the first one that I want to introduce to you is sine. So sine of theta is going to equal to the opposite side all over the hypotenuse. Okay, and keep this in mind. This is a review. So when we're talking about opposite and hypotenuse, we're talking about the lengths of each side. So sine of theta is equal to opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Okay, so there's a difference right there. And then the other one that you've seen before is tangent. So tangent of theta is opposite, so it's the opposite side all over the adjacent side. So remember, for you to figure out the sides, always start at this angle and then figure out what side is the opposite side and what side is the adjacent side, which is right here. Okay. Now those are the three main trig functions that you will be learning here, but there are three others that are a little bit less common. Well, they're not that they're less common, but they're going to be the reciprocals. So cosecant is the other one that we're going to look at. So cosecant is equal to hypotenuse over opposite. If you take a look at it, cosecant and sine, they're very much similar because they involve opposite and hypotenuse, but cosecant is the opposite. So when sine of theta was opposite over hypotenuse, cosecant was hypotenuse over opposite. Okay, so those two are reciprocals. Now let's take a look at secant. Secant of theta equals to hypotenuse over adjacent. Okay, so hypotenuse over adjacent. Now, that one right there is the opposite of cosine. So since cosine was adjacent over hypotenuse, secant will be hypotenuse over adjacent. And last but not least, we have cotangent. And cotangent of theta is adjacent over opposite. So the opposite of tangent. Tangent of theta is opposite over adjacent, and cotangent is adjacent over opposite. Okay, so keep that in mind. Those will be the opposites, the reciprocals that you will be learning. So just keep that in mind. Okay, I will pause it a little bit just so you make sure that you have the time to write it down. If you haven't, and then we'll proceed from there. Okay, now I expect you to write example number 1. So example number 1 is right here. I will go ahead and pause it right now, and then you will go ahead and write this down, and then once you've written it down, then we will go on and do the problem. Okay, so example number 1, it says find the values of the 6 trigonometric functions of theta. So take a look at what it asks. It says find the values of the 6 trigonometric functions. Okay, so make sure that you have a highlighter with you and also a red pen, and we're gonna go from there. Okay, so first we must find, I'm going to write this down, we must find sine, we must find cosine, we must find tangent, so those are the first 3, and then the next 3 will be cosecant, secant, and cotangent. Okay, so now we're going to go from there. So first, for us to find the values of the trigonometric functions of theta, we must have all 3 sides. So if you notice, you have 2 and you have 2 square root of 3. Now if you notice right here, this side is missing right here. However, if you can recall from geometry, we have a form that helps us find this side right here. That right there is going to be the Pythagorean theorem. So I'm going to go ahead and we're going to do the Pythagorean theorem real quick. And if you can recall, the Pythagorean theorem says that a squared plus b squared equals to c squared. Okay. Now, I'm just going to label our sides just for the sake of it. Remember, a and b will be your legs. So I'm going to let a equal to 2, and I'm going to let b equal to 2 square root of 3. And then we'll go from there. So now, I'm going to do this. I'm going to say 2 squared plus 2 square root of 3 squared equals to c squared. Okay? Once you do the math, you're going to get 4 plus 2 square root of 3, that's 4, because remember 2 squared is 4, and then square root of 3 times square root of 3 is 3, so it's 4 times 3, and then plus 12 equals to c squared. Okay? Now, you will realize that 4 plus 12 gives you 16, so 16 equals to c squared. And then now, for our last step, since we want to get rid of the squared right here, we're going to square root both sides. And so, square root of 16 is 4, so your 4 is going to equal to c. Okay, and then that means that now we have the hypotenuse and we have all the sides that we need. So therefore, this side right here equals to 4. Okay, so hopefully that's a review that you guys already know about in terms of doing a trig. Okay, now remember sine. If you can recall, sine is opposite over hypotenuse, which means that once we write it down, we're going to get that sine of theta equals to the opposite. But now take a look at this. Remember, you're trying to find the trig functions of theta. So you're going to start here at theta, and then we can label it. Watch. From theta, our opposite is right here. I'm going to just abbreviate opposite. Adjacent is this side right here. And then the hypotenuse is the side that's right across from the right angle. So this right here is the hypotenuse. Okay? Now, again, so now let's take a look. Our opposite is 2. So then sine of theta is 2. Your hypotenuse is 4. So it's going to be 2 over 4. And once you simplify that, you're going to get 1/2. Okay? Now let's look at cosine of theta. So we look at cosine of theta. Again, if we take a look at our previous ones, it's adjacent over hypotenuse. So adjacent over hypotenuse. Remember, your adjacent is 2 square root of 3. So you get 2 square root of 3 all over your hypotenuse, which is 4. And then again, you simplify this more. So then you get 2 over 4 should give you 1 at the top and 4 at the bottom. So you get square root of 3 over 2. Okay, and that's your cosine. Now, tangent. Tangent is opposite over adjacent. So I'm going to put opposite over adjacent. Your opposite, again, if you start at theta, is 2. So tangent of theta will give you 2 all over the adjacent, which is 2 square root of 3, which will give you 1 over square root of 3. But remember, if you recall from algebra 2, we don't like radicals at the bottom, so you're going to multiply the top by square root of 3 and the bottom by square root of 3. And so your answer is going to be square root of 3 all over 3, because square root of 3 times square root of 3 gives you 3. Okay? So I'm just running out of space right here, but there you go. So you have your sine, your cosine, and your tangent. Cosecant. Now take a look at this, watch. Your cosecant is simplified. So remember, your cosecant is hypotenuse over opposite, which means that you're going to find cosecant of theta, which is hypotenuse over opposite, and then the hypotenuse is 4, your opposite is 2. 4 over 2 gives you 2, and that's your cosecant. Remember, this is easy, you guys. Remember, you just gotta focus on your theta, and then just look at what side's your opposite, what side's your hypotenuse, and what side's your adjacent. Okay, so there you go. Your secant, remember, it's hypotenuse over adjacent. I almost made a mistake right there. Hypotenuse over adjacent, remember, it's the very opposite of cosine. So that means that secant of theta, and we're gonna abbreviate it as secant like that, is your hypotenuse, which again is 4, all over your adjacent, which is 2 square root of 3, which again will give you 2 over square root of 3 once you simplify it. Again, just keep in mind, we don't want radicals at the bottom, so so you have to multiply by its conjugate. So then 2 times square root of 3 gives you 2 square root of 3, and then square root of 3 times square root of 3 gives you 3. So therefore you have 2 square root of 3 all over 3. Okay, and that's your secant. Last but not least, let's look at our cotangent. Cotangent of theta is adjacent over opposite. So I'll write this down right here. Adjacent over opposite, which means that it's 2 square root of 3 all over 2, and then 2 divided by 2 is obviously going to cancel out, so your answer is square root of 3. And there you go. That's the answer that you want to see. Okay? Now I'll go ahead and pause it just for a little bit for you guys to write everything down, and then we'll move on to the next problem. Okay, so hopefully that was a bit of review. Now we're going to go on to the next concept. So first, I will have you guys write this down right here. So I'll have you write it down, and then we will proceed from there. Sorry, one moment. There you go. Okay, give me 1 moment to write this down, and then we'll go from there. Okay, just to kind of explain what angles of elevation and depression are, is this is going to be very applicable because once you start looking at word problems, you're going to be having a lot of situations where you're looking at where you're going to be having to create triangles in real world situations, and you have to be able to distinguish between angle of elevation and angle of depression. So when you talk about angle of elevation, you're talking about looking up. Okay, so think about it. Whenever you're looking at something elevating, that means it's rising, so you're going to be looking up. So your angle should be pointing this way. Angle of depression is going to be the opposite. So instead of looking up, you're looking down. So when something is depressed, not the so like depression, I know it's used in terms of like mental, just like mental health stuff, but depression could also be considered like when you're looking down. So when you have an angle that's pointing down, when they're talking about an angle of depression, just think of looking down. And here's another diagram to represent it. Okay, so angle of elevation, it should be this angle right here, the one that's pointing this way, and then angle of depression is the angle that's pointing down. Okay, give you a little bit more to draw that, and then we'll go from there. Okay, now example number 2. So okay. Alright, so go ahead and write this example down. I will give you a couple minutes to write down example number 2, and then we'll proceed from there. Okay, example number 2. So it's saying a surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the mountain at 78.3 degrees. How tall is the Washington Monument? Okay, so first let's highlight some key factors. So again, it's saying it's standing 115 feet from the base of the Washington Monument. It also says that it measures the angle of elevation. So okay, that right there is very important because that right there is going to tell you whether the angle is pointing up or down. Okay, and then it tells you that the angle is 78.3 degrees. And it's saying how tall is the Washington Monument. Okay, so let's go ahead and let's draw a little diagram for ourselves. Okay, so I'm gonna go ahead and do like just a mini sketch, something like that. And then okay, so we're gonna draw this let's see, this mountain right here. Let's do my best. And then this right here is the top. So the surveyor is gonna be standing right here. So remember, just draw like a little stick figure of someone right there. So they're saying that they're standing 115 feet from the base of the Washington Monument. So right here, you guys, is the base. So remember, the base is the bottom right here. So that means since it's standing 115 feet, and that means right there we have 115 feet. Okay? It's 115 feet. Okay, that's our triangle right there. It's saying that the angle of elevation, so remember, we're taking a look at an angle that's it's going to be starting from, it's going to be pointing up. So the angle is 78.3. Okay, So we draw our little triangle right there. Okay, so we're gonna be drawing like an angle right there, and then we go from there. Okay. And remember, it makes a right angle, the base and the mountain, and then this angle right here is 78.3 degrees. And remember, it's elevation. Okay. Now it's asking how tall is the Washington Monument. So in other words, they want us to figure out. Sorry, one moment. This camera takes a while to focus. They want you to find how tall it is. So this area right here, they pretty much want you to find like how tall it is from here to here. Okay, so they want you to find x. Okay, and that's what I'm gonna figure out right there. Now let's think about our trig ratios. So if we think about this side right here, remember, since it's right across, this side is right across from the angle, this side right here is our opposite, so I'm gonna abbreviate it as opposite. Okay, this side right here is right next to the angle, so this right here is gonna be adjacent. Okay, so we're gonna label that adjacent. Okay, so since we have an opposite and adjacent, we're gonna be looking at tangent. So I'm gonna write this right here. Where tangent of theta equals to opposite over adjacent. Okay, now we gotta take a look at what we have. So do we have a theta? Yes, we do. We have that angle right there. So now I'm going to rewrite it. So we have tangent of, I'm going to put it right here in the inside, I'm going to put 78.3 degrees. Yeah, the 78.3 degrees equals to, remember, you have your opposite. So your opposite is your x, so we don't have that. So it's going to be your x all over your adjacent, which is 115 feet. Okay? Now, since we want to find x, we're going to multiply both sides by 115. So I'm going to multiply this side by 115, and then I'm going to multiply this side by 115. Okay? And so now, what's going to happen is that this is going to cancel and that's going to cancel. Okay? So then, once you write it down here, your x equals to 115 feet times your tangent of 78.3 degrees. Okay? So now that I have my x, I'm going to simplify that. So 115 feet times tangent of 78.3 degrees. I'm going to go ahead and put it in my calculator, so the calculator on my phone. Just FYI, make sure that when you're inputting your values, that you're using that you make sure that your calculator is in degrees. So right here, we're in degrees. So if I click it, it's going to make it into radians. You want to make sure that it's in degrees. So I'm going to put 78.3, take the tangent of it, and then I'm going to multiply it by 115. So then it should give you about 555.3 feet. Okay, so then your answer is about, again, 555.3 feet. And don't forget the feet, because when it comes to trigonometry and it comes to real world situations, you want to make sure that you round it off as much as you can, because if you're putting, if you end up just putting 555, like, I'm not going to know exactly what you're referring to, and that's not a good position to be in. Okay, so I'll go ahead and give you a couple more seconds to write that down, and then we'll go from there. Okay, last example for the day. So go ahead and write down example number 3, and then once you have written it down, sorry, bear with me, just the zooming thing takes a while to zoom. Okay, once you've written it down, then we'll continue from there. Okay, so now it's asking us to find x. So now let's take a look at what we have. So we have this right here is 32.5 inches, and then this angle right here is 62.3 degrees. They also give us that this angle right here is 55.2 degrees, and they want us to find x, which is this side right here. Now, just if you take a look at it, since this is a right triangle right here, this must also be a right triangle right there, because this right here is perpendicular. So I'll just draw a little box right there just to symbolize that. Okay? So now take a look at this. If I wanted to find this side or that side, it would be impossible because I have no sides given to us right here in this triangle. So that means that we really don't have enough information to solve for x directly. Okay? Since I don't have this side or that side. But let's take a look at this little triangle right here. Take a look at it. We have an angle and we have a side. The beauty about trigonometry is that once you have an angle and a side in a right triangle, so if you have a right angle, like an angle and then a side, then you're good to go. So if you take a look at this one, so you could ignore this triangle right here for a little bit. And if you take a look at it, you have this side right here, 32.5 inches, and then 62.3 degrees. Okay? So remember, we want a side. We want to be able to find the side on this triangle here first, so we're able to find x. So this side right here is not going to pertain anything to us. But if you take a look at this one, this side right here is shared by both this triangle and that triangle. So I'm going to go ahead and I'm going to just put a question mark right here. Okay? Now, take a look at it. This angle right here, we're going to start right here. You're going to figure out the sides for each of them. So this angle, since it's right across, this side is right across from this angle, this right here is our opposite. So remember, make sure to label that for yourself because it'll make it easier for you to understand. This side right here, remember, since it's right across from a right angle, this is your hypotenuse. So then now, I'm going to find my opposite side. Since we have the opposite side and the hypotenuse, we can only be looking at two things. We could either talk about sine or we could talk about cosecant. But for this case, just to make it easy for ourselves, we're going to look at sine. So I'm going to put sine of, here's my writing right there, sine of 62.3 degrees equals to your opposite, which again I'm going to put as a question mark, all over your hypotenuse, which is 32.5 inches. Okay? Then we can go from there. Again, since we're trying to find this question mark right here, I'm going to multiply both sides by 32.5 inches. So multiply by 32.5 inches, multiply by 32.5 inches, and then this cancels, and then, so now, you'll have that your question mark equals to 32.5 inches times, so it should be 32.5 inches times your sine of 62.3 degrees. Okay. Now, again, I'm going to go ahead and input it into my calculator. So if I put it right there, again, make sure that it's in degrees and radians. I'm going to first take the sine of 62.3. So 62.3, take the sine of that. That gives you 88.885. And then I'm going to multiply it by 32.5. So then your answer ends up being about 28.77, so I'm going to just round that up, so about 28.8 inches. Okay? And there you go. So now, that's what you have right there. However, is that what we really want? No, because remember, we want to find x. So this side right here, remember, I'm going to just label it again. It's going to be 28.8 inches. And then we can go from there. But now take a look at it. If you see, you're trying to find x, but we have another angle right here that we could look at. So now take a look at it. This angle right here is the opposite. This side right here is the opposite from that angle, and this side right here is the adjacent. So your x is going to be adjacent. Okay, so now you have another thing you could focus on. Since you have an opposite and an adjacent, then that means that we could have tangent now. So now tangent of 55.2 degrees is going to be your opposite which again is, you already have your opposite, that's 28.8 inches, all over your x. Okay. So now I'm going to go ahead and then, since we have the x at the bottom, I'm just going to cross multiply. So I'm going to cross multiply like that, and then like this. And now you should have x times tangent of 55.2 degrees equals to 28.8 inches. And one last thing, since I want the x by itself, again, you have to divide it. You have to divide both sides by tangent of 55.2 degrees. Tangent of 55.2 degrees. These will cancel. And so I'm going to bring my work up here. Your x equals to 28.8 inches all over tangent of 55.2 degrees. Okay, now input it into your calculator. So again, 28.8 divided by tangent of 55.2. I'm going to go ahead and do the tangent first. So again, so you're going to put 55.2, take the tangent of it. So your tangent, as you see, it's about 1.43. Okay, so then I'm going to go ahead and write that down. So 28.8 divided by 1.43, and I'm going to divide it. So then I'm going to have 28.8 divided by 1.43. And that should give you about, so you bring it down, you should get about 20.1 inches. Just bring it up a little bit more. So you should get about 20.1 inches. Okay? So that concludes the lesson for us. Remember, so for you to do the homework, make sure to log on to Schoology. The assignment will be right there. If you have any questions about the lesson, feel free to watch the lesson again. You could ask me for any other questions, and then we'll go from there, and then do the assignment, and then we'll answer questions next time we see you. Okay? All right. Thank you so much, you guys.